Question 2, we're looking at someone running. A boy runs along a track as shown above. During section X, he runs with a constant speed of 2 meters per second for 15 seconds. So the amount of time it takes him is 15 seconds, and he's running at 2 meters per second during section X. Okay, there's the advantage of having different colours. During section Y, he runs with a constant acceleration, so not speed, as we've seen in the first one, but a constant acceleration of 0.2 meters per second per second. 0.2 negative 2 meters per second squared. And that's his acceleration during section Y. Well, calculate, this is A, calculate the net force acting on the boy. He has a mass of 60 kilograms during section Y. Give an appropriate unit with your answer. Okay, as a mathematical question, the best thing to do is to, because it says calculate, that's why we know it's mathematical, so the best thing we can do is list all the things we know in an orderly fashion. We know the mass is 60 kilograms. We know during section Y the only other thing we actually know is the acceleration, which is 0.2 meters per second squared, meters per second per second. Okay, and we have to find out the force. And straight away, if you're familiar with the equation that links these, and in doing problems, that familiarity should have become clear in your exam preparation, your test preparation, you'd find the equation is F equals ma. This is Newton's second law. And so we just substitute in the mass and the acceleration to multiply out 60 times 0.2, and we end up with a force of 12. 60 times 0.2 is 12. And the units for force, says give an appropriate unit with the answer, the units are newtons. Newtons. Okay, let's write that out in full, newtons. After Sir Isaac Newton, and F equals ma is Newton's second law. So that's where the unit comes from. Moving on to B. The boy runs 12.5 meters during section Y in 5 seconds. Okay, I'm just going to circle this information. We're in section Y still, so I'm going to go back to my red. So 12.5 meters, 5 seconds. Calculate the power required, this is again mathematical, calculate the power required by the boy to produce the constant acceleration of 0.2 meters per second per second. And again, give an appropriate unit with your answer. Okay, so we're trying to find the power. Power is question mark. And the units. We know the distance covered is 12.5 meters. We know from the previous question, we know the force that's applied during this time, which is 12 newtons. And we know the acceleration, which is 0.2 meters per second squared. And we also know, the time, which is 5 seconds. Excuse me. So the way forward with this is clearly a little bit trickier than the above question because there's a lot more variables involved. So we should look for a formula that you link all of these things, of course, same process. However, I would start with the power this time because that's my intuition in this. With practice, you'll see why. And in this case, the power formula is energy converted over time or work done over time. Okay, and I also know, just to put this in there, that the work done is the force times by the distance over which that work is done. So we could modify this equation to be F times D over T. And that'll give us the power if we have the force, which we do, there it is there, if we have the distance, which we do, and if we have the time, which we do. So we're now actually in the right position. You will notice that the acceleration is not required in this question. However, we did need it to work out the force initially. Okay, so let's plug these numbers in to get our, it's down here, force times distance, so it's 12 times by 12.5, which is about 150 I believe, and then you're dividing it by 5 seconds, which should give you 30. And the units for power are watts. You might have had a little bit of fun with your teacher when they say to you or ask you, they say, what is the unit for power? Or they could state it, what is the unit for power? And you wouldn't know if they're asking you a question or if they are telling you what the unit of power is. Okay, I'll leave that one alone. That's a favourite of mine, my lame physics jokes. Calculate the speed, this is part C, part 1, calculate the speed of the boy as he reaches the end of section Y. Okay, so he's been accelerating at a rate of 0.2 meters per second squared for a time of 5 seconds, and the velocity is we're trying to find the speed of the boy, so the change in velocity is your difference between your final and your initial velocity. And if we cruise back up to the top, we're told, you can see here, during section X he's at a constant speed of 2 meters per second. So it's irrelevant how long he was at that for, but that means he's at 2 meters per second for the start of that section, and then he begins accelerating from 2 meters per second. Was it 2 meters? Oh no. Yes, 2 meters per second. Okay, coming back down. So this will be an unknown, Vf, minus 2 meters per second. And if we put these into a formula to link them all, we know that the acceleration is the change in velocity over time, or the change in time. I'll rearrange it just a little bit first. A times t equals change in velocity, and the change in velocity was the final minus 2. So we can rearrange this one step further. I have to bring it out to the side here to be, let's just bring it up here. So we can rearrange this one step further to say AT plus 2 equals VF. A was 0.2, T was 5, plus 2 equals VF, so 0.2 times 5 is 1, plus 2 is 3 meters per second. There we go, so that's our answer, which you would write in there. Coming back down. Part 2. Use this and other information provided in the question to complete the speed time graph below. On your graph you should label the speed values on the vertical axes, so that's the amount that we're looking for, so the actual amount. Remember, during section X it's going 2 meters per second, so X is going 2 meters per second, and then from Y they're going from 2 up to 3 meters per second. Okay, at a constant acceleration rate. So we've got to label the speed values. We also have to draw a line on the graph to show the speeds for section X and section Y. Okay, so that's what we're getting at. So we start off, for the first 15 meters he starts at a speed of 2. So let's make this scale nice. 1, 2, we've got 1, 2, 3, 4, 5, 6 divisions. If I make this 1 and this 2, no, that won't work. 1, 2, 3 meters per second. Then he's going to start at 2, and he's going to continue along at 2 until bang, he hits 15 seconds, and then for the last 5 seconds, constant acceleration up to 3 meters per second. So we'll just double check we've got everything. Have we got the speed values on the vertical axes? Yes, we've got those speed values there, there, and there. It's just really labelling the graph and choosing the scale, and we've drawn a line to show the speeds for section X and Y. Yes, we have. So that is fantastic. Are there any more questions below? That's it.